Algebra 1, Common Core, Unit 5, Section 3. What is a line? A linear equation or a straight line is an equation of degree 1. So I'm going to highlight some pieces of this. Sorry if it came out a little fuzzy on your screen. So a linear equation is degree 1. And what that means is the largest exponent is 1. So if you look at, a linear equation like y equals 2x minus 1, something like that. The exponent of x, notice that we don't have an exponent written. Well, that means that the exponent is 1. You will see equations that have x squared. That would be a quadratic equation, or equations that have x to the third. That's called a cubic equation, right? But we're just talking about linear equations in Unit 5. And so all of our equations, we're not going to have anything squared or any exponents other than 1. So we actually won't really see the exponent written very often. So to write a linear equation, you need to know two things. To write a linear equation or to draw a line, you need to know two things, two very important things. Those two things are the slope or steepness of the line and its location. And for location, we usually refer to it as where it hits the y-axis. The y-intercept, the location of where it intercepts the y-axis, known as the y-intercept. To draw a line, I need to know basically how it's angling, because I could draw a line like this, or I could draw a line like this, or I could draw a line like this, right? They have different steepnesses, different slopes. But I also need to know where it is. If I'm drawing a line with this slope, should it be here? Should it be here? Should it be here? Should it be here? So we need to know how steep the line is and where it is. And so we need to know a point on the line. The most common point we look for is that y-intercept, where it is on the y-axis, the vertical axis. And we need to know its slope, its steepness. The incline or decline of the line. You're going to see linear equations in two very common forms. The most common form is the slope-intercept form. And that we call y equals mx plus b. For example, y equals 2x plus 3. And it has a y and an x, and remember, instead of y, we could see f of x. We learned about the function notation in this chapter too, so we'll see that instead of y equals, but that's the same thing as y equals. And this is the standard form, standard slope-intercept form, it's known as. The coefficient of x is m, and m we use to represent slope. So this line has a slope of 2, and b represents y-intercept. So this particular example I'm showing here has a slope of 2 and a y-intercept of 3. Now slopes really need to be fractions, so we could just think of that as 2 over 1. Sometimes they're whole numbers, we'll put it over 1, sometimes it's a fraction to begin with. B, the y-intercept, we just want it to be a 3. And I'm going to talk more about what this stuff means, and we're going to spend several days on graphing linear equations. A lot of this you probably already know. But that's a very common form you're going to see. Another form you're going to see, which is probably new for you, is called the point slope form. And that's right here. Y minus y1 equals m parentheses x minus x1. Again, we have m to represent slope. M always represents slope. And we still have y and x, but instead of a b, we have an x1, y1. Basically, because b is our y-intercept. Well, what if instead of the y-intercept, we just have a random point on the line? We said we need to know the location. Location doesn't have to be the y-intercept. It could be any point on the line. So if we have any point on the line, that's represented by x1, y1. For example, let's say we know the slope of a line is 1/4. Again, I'm going to talk more about that what that means in a minute. And we know the line is on the point 3, -4. Well, in slope-intercept form, that would be y minus the y value of the point you have. And when we minus a -4, the minus negative becomes plus. So we'd write it as y plus 4 equals 1/4 parentheses x minus 3. Again, that's your y minus your y value equals your slope m parentheses x minus the x value. And again, we're going to spend entire specific days dedicated to y equals mx plus b and the point slope formula. So we can represent lines in either form. Now, vertical and horizontal lines are interesting, and we're going to talk a lot about all of this stuff. We're kind of just getting into linear equations. We're going to talk a lot about this. I keep saying that. We're going to keep talking about this, right? But vertical and horizontal lines are interesting because they don't necessarily have to have a y-intercept. And what do you do for a slope of something that's like this, or a slope of something like this? So we'll see that when we get a little bit further down here. But hold on to that for a moment. Now, the one note about vertical and horizontal lines is horizontal lines we see as y equals, but vertical lines are the only linear equations that start with x equals, and they don't have a y at all. They don't have a y because they don't cross the y-axis. And so we'll talk more about that in a minute. But now, slope is a big part of this. And, again, we talk, our next lesson, 5.4 is all about, slope formula, and then we're going to get into intercepts. So we're going to talk a lot about all the specifics here. But slope in general is like the steepness of something. And we think of it, we use the letter m always to represent slope, and it's the change in y over the change in x. Rise over run is a very common way of representing it that you hear a lot of teachers use that language, rise over run. But always remember the y over x. M equals y over x. How the y-axis is changing, how it's changing vertically over how it's changing horizontally. For example, on this little line segment we see here, and we always go left to right, just like I'm reading this sentence from the left going to the right. That's the same way we read slopes. We start on the left and we go to the right. So starting on the left of this graph, that's point A. To get to point B, I go up 1, 2, 3, and over 1, 2. That's why my slope here is 3 over 2, because it's up 3 over 2. And what this is kind of explaining that to you, that make sure you have to do y over x, because technically, like if I'm just giving directions, I could say go to the right by 2 and then up 3. But that's not how we represent slope, and we need to be consistent in mathematics. So we always do y on top. The confusing part is if I'm going to state like this coordinate here, like point B is the coordinate 1, 2, 3, 4, looks like 4 or 5, 4 comma 5. Notice that x is first, y is second. Well, but when we're doing slope, we tend to think of y first, x second, because we do top first, bottom second. So you have to kind of be able to shift back and forth, that when I'm stating coordinates, it's x comma y, but when I'm talking about slope, it's y over x. Now there's really 4 different types of slopes you're going to see. Positive slopes, like we just saw there, and they're inclines. Again, starting on the left, if you were walking up this line, you're going uphill. It's exhausting, right? The steeper the slope, the larger the number, the more incline and the more tired you're going to be walking up that hill. Negative slopes look like declines. They go down. So instead of like up 3 over 2, it could be down 3 over 2. And so they are going down. This would be a negative slope. So this is a positive 3 over 2. This is a negative 2 over 3. Horizontal lines, like we were talking about before, they're flat lines. They have a slope of 0. I often use the analogy of the treadmill. Like you could set the incline on a treadmill. Well, if your incline is set to 0, your treadmill's flat. And then as you increase the incline, it gets steeper and steeper and steeper. But vertical lines, what do you call that slope? Well, it doesn't really work. It's something called an undefined slope. And it has to do with because your fraction is over 0. When we get to slope formula in the next video, we'll talk more about why that is the case. But vertical lines don't have slope. We can't put a number value to it. Okay, so a little bit of practice here. What we could do in this lesson for practice is determine the slope of a linear equation, and I could get that from its equation form or from its graph form. So let me just run through a couple of these. First, these first 3 examples are in y equals mx plus b form. And the easy way to tell is y is alone on the left, then it's followed by something with x, like a number x, and then followed by a constant. And so it's really just looking at the coefficient of x. So this one, the slope is 2/3. This one, the slope is -2. And I can put it over 1 because we like a fraction, right? So that means down 2 over 1, not just down 2. So we always got to be a fraction. Here, remember when there's no number in front of x, there's a 1 there. So this slope is 1, and that can go over 1. So that's up 1 over 1, up 1 over 1. These down here in the bottom row, they're not in y equals mx plus b standard form. But these first 2 are pretty easy to get that. And a lot of times you need to do that. So we want to get it to be y equals. We want to solve for y. So all I can do here is I can add that 3x over to the other side. Now this 4 plus 3x, these are not like terms. So I can't combine them together, but that's okay. I don't want to. I want to just put them next to each other. What should go first? Well, the mx should go first. That's the 3x. And then the 4 goes second. It's a positive 4, so plus 4. So I can see here my slope is 3, the coefficient of x. And we put it over 1. This next example is a little bit more work to get y alone. First, I add or subtract things away. I can minus 5x. So that's going to be 2y equals, again, that x term goes first, the negative 5x goes first, and the positive 8 goes after that. And then to solve for y, I can divide everything by 2, because I want just y equals. So get that little box out of there. Y equals negative 5 over 2x, and it's never a big deal when your coefficient of x is a fraction, because our slope is naturally a fraction, so that's very normal. Plus 4. Our y-intercept, that does tend to come out to be a regular whole number. So our slope here is the coefficient of x, negative 5 over 2. And this last one, I could distribute this half and get it to be y equals, but what you notice here is this is in that point slope form. And in that point slope form, just to go back to this for a second, y minus y1 equals m parentheses x minus x1. Again, we'll spend a lot more time on this. This is my slope right here. So m just simply is a half. And if I were to distribute this and move things around, we would end up with a y equals 1/2 x something. All right, but how about from a graph? Well, from a graph, first of all, like this horizontal one is easy. That's a flat line, so it's just slope of 0. And vertical lines, our slope is what we say is undefined. You can't do that slope. But then these ones that are not vertical and horizontal, we want to use a couple of points to count. Now, first of all, this is a positive slope. It's an incline, and I see that it's up 1, 2, 3, 4, 5, and over 3. So my slope here is 5 over 3. This e to f here is a decline, so it's going to be negative. It's going to be negative something. This looks like it's going down 2. So negative 2 over 1, 2, 3, 4, 5, 6. No, wait, hold on. 1, 2, 3, 4, 5, 6. Negative 2 over 6. Now this can be reduced to negative 1 over 3. That's important. You want to reduce your slope if you can, because what that means is I can go down 2 over 6, or I could do a bunch of little steps of down 1 over 3, down 1 over 3. See, when it was like 5 over 3 for GH here, you had no choice but to go up 5 over 3. The last one, AB here, is another negative slope. If I do it in one shot, it's down 1, 2, 3, 4, 5, 6 over 3. So that's a slope of negative 6 over 3, which reduces to negative 2 over 1, because I could have just gone down 2 over 1, down 2 over 1, down 2 over 1. So it's rise over run. Big part of it is recognizing when it's a positive or a negative slope, and don't fall for the horizontal and vertical tricks there. If it's in equation form, you want it to be y equals. That's where it's easiest to see. It's just the coefficient of x, and you may have to move things around to get it to be there. All right, that's 5-3. What is a line? See ya.